Hello and happy Wednesday. This video is meant for students who have already completed Tuesday's work, the independent and dependent worksheets and extra practice that I asked you guys to do either on a separate sheet of paper or printed out. This video is going to go over all of those, so hopefully it should eliminate any questions that you guys have. So please don't watch this video unless you've completed these assignments. And once you complete them, then you can go back and check your answers. So for this, I encourage you to pause the video and just check your answers. My red is independent and blue is dependent. But I'm going to move on to go over more in depth the next two worksheets. So we'll start with this one. Here, so first you're just saying whether the event is dependent or independent. So remember, dependent means it depends on, the second event depends on whatever happened on the first event. Two events that kind of have, are affected by each other, whereas independent is the opposite, and it's two events that have nothing to do with each other whatsoever. Whatever happens on the first event doesn't affect the second event at all. So number one, it says one tossed coin landing on heads and the next landing on tails. This would be considered independent because you can toss a coin however many times you want. Whatever you got the first time is not going to affect the second. Number two, rolling 2 6s in a row on a number cube. Same thing, also independent. Whatever you roll, if you roll a 6 once, doesn't mean you're necessarily going to roll a 6 again. Number three, drawing a red tile from a bag and then drawing a green tile after replacing the first tile. So also independent. You replaced the first tile, meaning you have the same chances as you did the first time you picked the red tile and then the second time. So that's also independent. And then number four, drawing a blue tile from a bag, then drawing a red tile without replacing the first tile, meaning you kept that first tile, that blue tile out, meaning your chances for the second drawing is going to change because you already pulled one of them out. So this is the only dependent one here. All right, 5 through 7, it says these problems refer to rolling a number cube, then spinning a spinner with the letters A through H on it. Find each probability. Show all work. So number 5, rolling a 2 on a number cube. That is 1 out of 6. Then, again, because this is compound probability, we're multiplying, spinning an A. So how many letters are between A through H? A, B, C, D, E, F, G, H. So 8. So we have spinning an A. So there's obviously 1 A out of 8. So 1/6 times 1/8 is 1 over 48. Number 6. Oh, by the way, these are all completely independent because rolling a number cube has nothing to do with spinning a spinner. Two completely separate events. Number 6, rolling an even number and then spinning a vowel. So rolling an even number would be 1 out of 2 because 3 out of 6 simplifies to 1 out of 2, and then spinning a vowel. So we have A and E. So 2 out of 8 or 1/4. I'm just going to simplify that to get 1 out of 8. Yes, that's correct. Sorry to double check that. All right, number 7, rolling a number less than 3, and then spinning a consonant. So rolling a number less than 3, that's 2 out of the 6, which simplifies to 1/3, and then spinning a consonant. So everything that's not a vowel would be 1, 2, 3, 6 out of 8, which simplifies to 3/4. So we'll do times 3/4 down here. And we get 3/12, which simplifies to 1/4. All right, moving on, 8 through 11. Let's use a different color here, purple. So tell whether the events are independent and dependent and find each probability. So we have 5 gray, 4 red, 5 white, 2 green, and 2 navy marbles in a hat. So let's figure out what that totals to. 5 plus 5 is 10. 4 plus 4 is 8, so 18 total. Hopefully I did that right. 4, 8, yeah. So let's talk about the words with replacement and without replacement. With replacement means you're pulling out a marble and then you're putting it back in. Without replacement means you're pulling out a marble and leaving it out. Okay? So with replacement is always independent, whereas without replacement is always dependent. Because if you don't replace it, your odds change. So number 8, probability of picking a red marble first. So red would be 4 out of 18. And again, we're multiplying. And then not green. So anything but green. If there's 2 green, that means there's 16 that are not green. And that's still out of 18 because you are replacing it. Okay, so the 18 stays the same because you put the marble back in, the original marble. All right, so let's do this. So it ends up being 16 over 81. Number 9, probability of picking a navy marble. So we have 2 navy out of the 18 marbles times, and then this is without replacement, meaning you now pulled out a navy marble and there's 1 less marble in the bunch. So this decreases to 17 because you're not putting it back in. Then this is white, which is 5 white. From there, oh my god, I don't know this. 10 over, all right, so I think it's 5 out of 153. It's very small. All right, number 10, probability of picking a gray and then gray with replacement, meaning it's independent. So gray, there's 5 gray out of 18, and you put the gray back in, so the odds of picking another gray still stay the same, 5 out of 18. I'll do that math in a second. And then for 11, it's going to be a little different because it's without replacement, so it's dependent. So it'd still be 5 out of 18, but think about this. You now took a gray marble out, so there's 1 less gray marble, and there's 1 less total marbles. And then we go ahead and do that. I believe those are the answers. I don't have a calculator, so I'm doing this by hand. Okay. Moving on to the next even number. Whoops. So numbers 12 through 14, you roll a number cube, or you roll a cube with the numbers 13, 16, 18, 20, 22, and 24 on it. You then spin a spinner, which has 6 sections. The letters on the spinner are E, B, G, K, D, and H. Find each probability. So probability of picking G, and then a prime number. So we have the letters. Okay, so 1, 2, 3, 4, 5, 6 sections, 1G out of 6. Times prime numbers of here. So let's see. One of them is prime. So 1 out of 1, 2, 3, 4, 5, 6 again. So 1 6 times 1 6, 136. Number 13, probability of picking a 20. So there's just 120 out of 6, and then a K, 1K out of 6, 1 out of 36. And number 14, not an even number. There's only 1 odd number here. 1 out of 6, and then B or D. That would finally gives us 2 out of 6. So 2 out of 36, which is 1/18. All right. So again, all of this, because whatever you spin on the spinner has nothing to do with the number cube, so this is all independent. So the denominators don't change, the numerators don't change. It's just 2 separate probabilities multiplied together. All right, numbers 15 through 17. Suppose that 2 M&Ms are drawn from a bag of M&Ms that contains, okay, so 5 green, 8 brown, 6 red, 4 orange, and 9 blue. So we have 10, and nothing else is easy to add together, so 17, 27, and then plus the 5 gives us 32, right? Yeah, so 32 marbles, or nope, M&Ms. So probability, so okay, this is replaced. So think about, is replaced, is this going to be independent or is this going to be dependent? If it is replaced, it's going to be independent, meaning It's not going to affect what happened on the first time. You're replacing something, it's independent. So probability, I'm actually taking forever, so I'm going to pause this and write out the answers for 15 through 17 quickly. Okay, so I just wrote out the answers there just so you could check so that you don't have to listen to me. Hopefully at this point you're having a better understanding of what the difference is on how to solve them. But I really just, the directions are really just in the, like the paragraph here. Is replaced, is independent, is not replaced, is dependent. So that brings me to 18 through 20. So we're talking about the same bag of M&Ms, but the first M&M is not replaced. So what happens in the first event affects what happens in the second, affects the probability. So the probability will change, meaning this is dependent. It's dependent on the first event. So number 18 on the bottom here, probability of picking blue. So it's still at a 32. How many blue are there? 9. But because you took one of the blue out, it is now in your hand. Now there's only 8 blue in the bag and 31 blue total. So 9 out of 32 times 8 out of 31 gives us 9 out of 124 probability. Very small. Number 19, probability of brown, not red. So brown first. How many brown? 8 brown out of 32. And then again, not red. There's 6 red. So 32 minus 6 gives us 26. So everything that's not red is everything else. So 26, and then out of only 31 because you took a marble out. So 8 out of 32 times 26 out of 31 gives us 13 out of 62. And then probability of orange would be 4 out of 32, and then green would be, why can't I find green? 5 out of, again, 31. So 4 out of 32 times 5 out of 31, 5 out of 248. Okay, so hopefully watching this kind of, even if you didn't get these right the first time, hopefully watching this and listening to me explain it gives you a better understanding of the difference between the two and how to find the probabilities. Remember, this is called compound probability, so it's 2 probabilities. You're multiplying to find your final probability. All right, so as far as the next worksheet, this would apply to anyone who got, I believe I posted it. I know I had to edit because I forgot to attach it. This would be for you guys to just check your answers. So you can pause it here, zoom in, do what you got to do, and because I'm not going to go over every single one. And then I will show you the last page. Again, just pause the video, look at your answers, make sure you got everything. Ask me questions if you have it. Obviously, I'm not currently here in the video, but please message me. There's millions of ways to message me, which not many of you are taking advantage of, mind you. All right, so this is not the only video that I'm putting out today. I'm going to now show you how to do lesson 10.6. All right, adios.